Okay, so lesson 5 is on negative exponents. Okay, yet another lesson on exponents. But up until this point, all of our exponents have been positive. And it is a possibility that you could have negative exponents. So that's kind of what this lesson is about. What happens when we have negative exponents? So let's take a look at your opener. Okay, the table shows the approximate wing beats per minute for certain insects. Okay, so we're looking at a housefly and we're looking at a small butterfly. And this is their wing beats per minute. So a housefly can beat their wings 10,000 per minute, and a small butterfly can do it 100 times per minute. Number 1, write a ratio in simplest form that compares the number of wing beats for a butterfly to a housefly. So butterfly will be on top, housefly will be on the bottom. Okay, so if we take a look, the ratio is 1 to 100. It would be 100 over 10,000, and then it simplifies in lowest form to 1 over 100. Number 2 says write the ratio as a fraction with an exponent in the denominator and as a decimal. Okay, so if we write the ratio with exponents, okay, we have 1, but how can we write 10 or 100 as using exponents? Well, 10 squared, we know that 10 squared is 100, so we just changed 100 to 10 squared. Now to write that as a decimal, it's 0.01 or 100th. Like we would read this fraction, 1 over 100, or we say 1 100th. This is 1 100th, okay? Now, in this chart, they want you to complete the first 4 rows of the table showing the exponential and standard forms for the power of 10. So here, in this column right here, this is your exponential form. This is your standard form, and standard form just means write it as a regular number, okay? So 10 cubed, if we write that as a regular number in standard form, we would get 1,000. Now notice, your exponent here is a 3. Look how many zeros you have. Okay. If we wanted to write 10 to a certain power, what would give us 100? Well, if we have 2 zeros, our exponent should be 2. What do you think how many zeros should we have here for this one? Yep, just 1. So 10 to the first is 10. Now, what if we have 10 to the 0 power? We haven't had any exponents with a 0 power. Well, looking at our pattern here, we go from 3 zeros to 2 zeros to 1 0. Well, if we follow the pattern, that means we should have 0 zeros. And that's right. 10 to the 0 power is 1. Now what happens when we go the other way? If we take 10 to the 0 power, our next logical step is 10 to the negative first, then 10 to the negative second, and 10 to the negative third. Okay, now that seems pretty simple going that way. Okay, now what happens to our standard form? Well, 10 to the negative first is 1 over 10, or 1/10, 1 over 100, or 1 100th, and yep, you guessed it, 1 over 1,000, or 1 1,000th. Again, it still is true with our zeros. We have 3 is our exponent. We've got 3 zeros, but notice it's on the bottom. It's on the denominator. Okay. What operation is performed when you move down the table? Well, what we're actually doing is division. We're dividing by a power of 10 each time. And what happens to the exponent? It decreases by 1. We go 3 to 2 to 1. But mathematically what we're doing is we're dividing by 10. Okay, and then extend the table to include the next 3 entries. Okay, so we did that. Okay. So this is just kind of a little preview of what we're going to be doing within this lesson. Let's take a look here. 0 and negative exponents. Okay. If we have a number to the 0 power, the rule is it's always 1. It could be 20 to the 0 power, it's 1. X to the 0 power is still 1. Y to the 0 power would be 1. Okay. Now, if it's not 0 and we have a negative exponent, what we're going to do is we're going to flip it and kind of write the reciprocal. So 7 to the negative third becomes 1 over 7 to the third. X to the negative nth power, we're going to flip it, and it becomes 1 over x to the nth. Notice when you flip it and write the reciprocal, the exponent becomes positive. Okay? So let's take a look at an example here. Write each expression using a positive exponent. So right now we have our negative exponent. Okay? We want to take this and we want to put it on the bottom so that it becomes positive. We just wrote the reciprocal, 1 over 6 cubed. This one becomes 1 over a to the fifth. Again, we're just putting it on the bottom to get rid of that negative exponent. Okay? All right, you have 4 got it problems. I want you to pause the video, and I want you to try A, B, C, and D. Write your answers out, and when you're done, you can unpause the video, and we'll check them. Okay, let's see how you did. Okay, 7 to the negative second. We want to get rid of that negative second exponent and make it positive. So to do that, we put it 1 over 7 squared. And then 7 squared is actually 49. So our answer is 1 over 49. Now if you typed 7 to the negative second in your calculator, you're going to get a decimal. And that decimal is actually equivalent to this fraction. Okay? But we don't want to have big long decimals. We want to have an exact answer. So 1 over 49 is the exact answer. B to the negative fourth. We don't want that negative fourth. Okay, so we're going to write the reciprocal, and it becomes 1 over b to the fourth. Now, this one's an easy one. This is a gimme. Anything to the 0 power is always 1. Okay, it doesn't matter what the base is. If the exponent is 0, it's 1. And D, m to the negative third, we want that 3 to become positive. In order to do that, we've got to write the reciprocal. So it becomes 1 over m cubed. Okay? Now, of course, it always gets harder, so let's try a couple of different examples here. Now we're going to go backwards. They want us to write each fraction as an expression using a negative exponent. So they're going to give us the reciprocal, and we have to change it back to a negative exponent. Well, if it's 1 over 5 squared, to make that to a negative, we just bring it back up to the top. We're just reversing it. Now this one, 1 over 36, if you look, we don't have an exponent. So what we're going to have to do is we're going to have to change 36 to 6 squared, because 6 squared is 36. Okay? But we want that 2 to be negative, so what we're going to do, we're going to take it and bring it up top. So it becomes 6 to the negative second. Okay? All right. Now, you've got 4 problems here. I want you to make these negative. So we're just doing the exact opposite of what you did on your first 4 problems. So pause the video, try these 4 problems, and then unpause it and we'll check them. Okay, now to take 1 over 8 cubed and make 8 cubed a negative exponent, we just make it 8 to the negative third. We bring it back on top. Okay, now f, you can write it as 4 to the negative first power, or you could have 2 to the negative second. Okay, you could also have this answer. That will be the same. Those two are equivalent. Okay? Now to make 1 over c to the fifth, if we want to take c and make that exponent a negative 5, all we have to do is bring it up top. So your answer is c to the negative fifth. Now this one we have to change. We're going to take 27 and write it as an exponent. Okay? So there it is as an exponent, because 3 cubed is 27. Now to take this and make that exponent negative, we need to take it, put it on top. When we do that, it becomes 3 to the negative third. Okay? All right, so there's the second thing. The third thing that we're going to do, okay, is we are going to look at powers of 10. Okay, now powers of 10 are very easy to change. All we have to do is count zeros. If you take a look at this decimal right here, we've got 1, 2, 3 zeros, right? Well, look at our exponent. We've got 3 right there. To make that negative, we bring it up top. So it's 10 to the negative third. Again, 1, 2, 3 zeros. Look at our exponent, 3. Okay, so it's 1 over 10 cubed. Bring it up top. It becomes a negative 3. Okay, now this one, I'll do this one with you. A water molecule is about that many meters long. Write the decimal power as a power of 10. Well, let's count how many zeros we have here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that means our exponent is going to be 10. Since it's a decimal, it's 1 over 10 to the 10th. Okay? To bring it up top, it becomes 10 to the negative 10th. This kind of goes along with our scientific notation that we're going to be talking about in the next couple of lessons. Okay? Okay, last thing. We're going to combine what we've learned about exponents so far with negative exponents. And this is what I'm talking about. You have to understand the different laws that we've been talking about. Look at this example right here. It says simplify each expression. We have 5 cubed times 5 to the negative 5th. Now we have the same base. So what we can do, we can add our exponents, just like we did last lesson. So 3 plus a negative 5 is a negative 2. But we don't want to keep it as a negative exponent. So what we're going to do is we're going to take that negative 5 to the negative 2 and we're going to put it on the bottom as a fraction. We're going to write the reciprocal. And 5 squared is 25. So our answer is 1 over 25. So we're combining what we're doing here. Let's look at the next example. Let me extend this a little bit here. Okay, it's a division problem. And with division problem, we subtract our exponents. So now we have the same base as w, negative 1 minus a negative 4. Negative 1 minus a negative 4. Well, negative 1 minus a negative 4 is 3. So our answer is w cubed. And you might be thinking, well, why aren't we putting it on the bottom and writing it as a fraction? Well, because our exponent's positive. And when the exponent is positive, we don't have to change it. Positive is good. Okay? All right, I'll do J with you, and then I want you to try K, L, and M on your own. All right, we have the same bases, so we're good to go. So since we're multiplying, we're going to add. What's negative 8 plus 2? Negative 8 plus 2 is negative 6. Now we want to take that, and we want to write it with a positive exponent. Well, we've got to flip it. So it becomes 1 over 3 to the 6th, which is 1 over 729. Okay? Now, I want you to pause the video, try K, L, and M on your own. All right, let's take a look. We've got a division problem here, so we have to subtract. So we go 2 minus 4. Well, 2 minus 4 gives us a negative 2. We don't like negative exponents. We have to make it positive. So let's write the reciprocal. 1 over 2 squared, which 1 over 11 squared. 11 squared is 121. There's your answer. Okay? Multiplying again, let's add. What's 9 plus a negative 4? It's a positive 5. Well, since we have a positive exponent here, we're done. We don't have to change it. Positive is good. Okay, now we have a division problem here. So we want to go negative 4 minus a negative 7. Negative 4 minus a negative 7 is a positive 3. And again, we're good here. It's a positive exponent. We don't have to change it. The only time that you write the reciprocal and flip it is if you end up with a negative exponent. Okay? What I want you to do right now in your books, I want you to try the guided practice problems, and then that's what we will go over tomorrow in class when you get in. Okay?